Assalamualaikum everyone. This is about the sustainable concrete from waste material. So my name is Muhammad Nazri Ikmat and let's get started. So we know that concrete widely used in the construction. We can see it everywhere. It also heavily relies to the cement and natural aggregate, but it both actually have a negative environment impact. For example, cement giving to 8% of global CO2, while sand and gravel cause several ecological damage. So here is my research about how to use the waste material as a replacement for fine aggregate and also cement. For the problem statement here, we have a high CO2 emission from cement production, the over extraction of natural aggregate, saying sand and gravel is limited, and the limited of real world application of waste based concrete despite of promising lab result. Our objective here is to find the effectiveness of replacement waste material compared to the fine aggregate and cement and estimate the potential of CO2 in waste-based vs the conventional concrete, and lastly to investigate the compatibility with the existing construction practice and standard. So this research is really relevant to civil engineering since it offers a solution of waste material and resource conservation. It also provides a lab validation data and practice insight of the engineering, and also it can encourage use of alternative materials like in non-construction concrete application. So for the step taken here, I have do the literature review on the sustainable concrete using the waste material uh, for for crushing grade, plastic waste and others. And you see there is a lot of lab results, but the in real world data is still lacking. So I discovered that the waste material can be particularly replace cement and sand with the acceptable performance since the strength may slightly reduced but still in the standard, and there's a lack of explore of long span test site like creep test and shrinking test. So from studies from the lab, the replacing of 10% of to 30% of cement with sand and waste, and then conduct the some of the tests, we can produce the particle misdesign recommendation for the waste mesh design. Here is the result. We can see that concrete with the 10% to 20% of waste material replacement still can maintain at least 90% of the compressive strength and also reducing at least 50% per meter cube of CO2 in the concrete. So as a result, we can say that the waste material as a replacement is still suitable for construction, but with limit, which is the limits talk about the real world applications in mostly the waste material application used in the infrastructure than the actually high rise building or others. So as a conclusion, I can say that the waste material work as a replacement very well in the concrete since it still maintain the strength and above the standard. So that's all for me. Thank you.